All right, so we've built our model here and we haven't parameterized it at all. And we're going to go through each of these and hopefully get them right. We might make a mistake or two, and that's fine because typos and stuff need to be fixed. It's a common part of modeling. I could give you something I'd already made work completely and then had you follow the bouncing mouse, but that doesn't help us with error correction. So we're going to go ahead and go to our R0 here, which is, we've been being told, is 3.3. And that's how many people a person infects on average. So our min's going to be, and max is going to be 10. We'll put an increment 0.1 to make our slider a little more workable. Our infection duration here, 7 days. Min of 0. Max of 14. And okay. The fatality rate, we've been told, is 3%, so 0.03. The minimum is 0. The max is 0.3. And okay. We can change our sliders later if we want to. The initial population, 10,000. Min of 1,000. Max of 100,000. And okay. And then the susceptible fraction here is the susceptibles divided by the initial population. And then our infection rate is our susceptible fraction times R0 divided by the infection duration. All right, so that's, so if the infection duration is 10 days and R0 is 3.3, then your sort of base infection rate is going to be 0.3 per day. It's not necessarily constant like that. In this disease, you're way more infective early on than you are later on, which is one of the reasons it makes it hard to stop infections. All right, so I think we have all of the parameters in. I'm going to hit save, and now we just need to go get our equations going. All right, so the active infected is just infected. The susceptibles are minus infecting. The initial value, we should be able to say okay. We need to put initial population in there and we're good. Then our advancing is the active infected times the initial infection rate. I did not get to incubation time. I shouldn't have hit it down here. But the incubation time, we're going to start with 7. Min 1, max 21. And okay. And then initial value of exposed is 0. Our advancing is the exposed divided by the incubation time. Oh, incubation time divided by incubation time. Sorry. Mouse follies. Exposed by incubation time. And then the infected, we're just going to have to put an initial value. 5 people moved into your town. They came back from skiing in the Alps. They lied to you and said they were visiting their Uncle Sal in Florida. And then dying is the fatality rate times the infected. divided by the infection duration. And the dead, you just have to put an initial value in there. The immune, again, we need to put an initial value in there. And then the final thing we need to parameterize is our recovering. And that's going to be 1 minus the fatality rate, which is the recovery rate, sort of by definition, times the infected over the infection duration. And there's our system. We're going to click Save. We're going to click our synth sim. Yeah. And voila. It all worked. So we have our nice, where it goes out with the rates that we're told. This is sort of why maybe the doctors were saying it's not going to be over in 15 days. Once we started with 10 or 12, it takes off, and then it starts to flatten out in about 60 to 70 days. These are parameters that we have been told are what we should expect. And you notice that it doesn't get everybody, but it certainly gets quite a few people with these sort of parameters that we were told early on. But still, I bought into these parameters, and I put out some models that suggested that we would have out of 10,000 people susceptible, that we wouldn't have that many. Let's go ahead and crack that up, and you can see that having a much larger population into the hundreds of thousands just it increases how long this thing can go on. And so with hundreds of millions of people, the chances of that. So what is flattening the curve? I'm going to go back to right around our 10,000. What does flattening the curve mean? So let's go ahead and grab our R0. What if we could just get that thing a little lower, like down to about 2, meaning we find people and don't let them out, so their R0 is down. So then we have this lovely, well, we can't even see where it goes. So we're going to stop. We're going to go to Model, Settings, and instead of 100 days, now we're going to go to 300 days. And OK. And run it again, so we can sort of see where it ends. And it comes down fairly quickly. Once we turn, it comes down fairly quickly. So now let's go ahead and do our, get that back to 1.8. And so, wow, that's not really the greatest of greatest that we wanted. Now it's still lots of, did the dead come down when R0 went down? Let's go have a look at that. All right, so we're going to take that back to 3.3. That's been one of my concerns. All right, so the dead are at about 225 in this model, and we take it way down to, we're really effective, we make it half. The dead do come down a little while the infections come down, so maybe we do save a few lives by changing R0. The infectivity rate, the infection duration out here, the fatality rate, this is a thing we could, if we brought the fatality rate, if we had an effective treatment, then we could bring those way, 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 way down. So our healthcare professionals are trying to work on all of these. The policy people think they can do this sort of thing up here. I want to remind you that this incubation time is maybe longer, maybe not. See what happens. Go ahead and play with these and see what happens to the effect of these sort of things. And this is what disease modelers do. They're saying, Well, that infection duration, what if that's a lot longer? All right, well, then the dead we get sooner. Again, it just means that we're going to see that incubation times go up, that thing's going to be slower and longer, and so and it changes the number infected at a particular time. Some people think there are ways to get into these, and I'll show you a much fuller policy model with this. Let's go ahead and stop our setup, and we're going to finish that.